Hello and welcome to RCR Wireless News. Thank you for joining us today for our webinar on LTE, DAS, and small cell field testing best practices. I'm Kelly Hill, your moderator. I cover test and measurement for RCR, and I'll be leading the discussion today. We also have Emanuele Procaccioli, who is joining us from Dubai. He's a senior manager of networks and communications with Accenture. We have Bruno Jaguer, senior advisor to the CTO office at Expo. Paul Gowans, Mobile Marketing Lead for JDSU, and Scott Sumner, Vice President of Solution Development for Exedian Networks. Thanks to all of our participants today. I'm going to jump right in with a little bit of a carrier infrastructure update. As we look at the testing space, these are the numbers that are driving it. AT&T spending $17 billion to date in 2014 on wireline and wireless infrastructure combined, expecting to spend $21 billion for the year. They've reached their LTE target build and cover 300 million potential customers. For Sprint, they've largely completed their rip and replace network update right now, and they're working on their Sprint Spark 8 transmit, 8 receive deployments, as well as LTE. For T-Mobile US, we've got them covering 250 million potential customers, as well as as they continue to roll out their LTE and wideband LTE in 700 megahertz and 1900. And then Verizon, according to their latest numbers, they've spent $7.8 billion this year so far on their wireless networks, and they're deploying XLTE, which is how they're branding their additional capacity for LTE in the AWS One spectrum in more than 400 markets. So that's just a little bit of an update there on some of the spending that's going on that's driving network testing. So published today on RCR's website, we do have the field testing report that accompanies this webinar. Some of the takeaways from that report: small cells and DAS definitely bring their own unique challenges to field testing, especially when you start considering indoor versus outdoor issues, directional versus omni antennas, handoffs, and interference, particularly when dealing with PIM, passive intermodulation, as well as consumer devices. Analytics is actually increasingly informing field testing, as well as trying to reduce the amount of field testing that's being done. And there's a shift going on toward constant and real-time monitoring versus discrete field testing efforts. I think we'll definitely hear more about that today as well. Overall, smaller, lighter, and simpler test equipment is on the rise, particularly as network testing moves indoors. We're starting to see more applications, more backpack-based testing sets, etc. And you can download that report at rcrwireless.com. So now I'm going to hand it off to Emanuele, and please go ahead and talk to us about some of the trends that are informing next generation testing.
Okay, thanks, Kelly. So this is Emanuele Procaccioli. I'm a senior manager of Accenture Network Practice, and today I'm going to tell you something about how Accenture is approaching the new generation of mobile network testing. So Kelly, if you can move to the next slide. So here is the agenda: how network testing is evolving, how to reach the testing excellence applying 3 main levers that we see are the most valuable one, and then I'm going to present our holistic approach to the network testing. Next slide, please. So the starting point is the analysis of the as-is. Everything within mobile communication is becoming more and more customer-centric, and this customer-centric approach is also bringing new complexity that telcos operators has not been facing in the last years. So the usage of complex application and data transmission into the network is generating a different type of customer expectation. And finally, customers are not always able to distinguish between what is lacking network performances and what is just an over-engineering of the application they are using. And if you consider that everything is now running on an overlayer architecture in the network, where you are basically adding new technologies without dismissing the previous one, This is giving you an, let's say, a rough idea on how the volumes and the complexity of the network testing is increasing. And we think there is no way to go ahead with the standard approach to network testing. So going there and testing in a comprehensive way all the features and capabilities of the networks and be sure that everything is completely matching what you expected. You have to change the approach. You have to go for an holistic testing. Next slide. Going for the holistic testing, we see that you are going to face three main challenges. You have to take under control the cost challenges, so doing more and more testing, spending less. You have to be sure that your testing are at the right quality, because you cannot cover the complete no regression test cycles like in the past. You have to match with the always more challenging time plans. And moreover, you have to increase your productivities, because you are testing more, basically using the same resources. So next slide. We are answering to these three main challenges basically with the three main levers. First of all, we are industrializing as much as possible the network testing, introducing clear discipline, clear methodologies, testing libraries to be reused, and clear processes to be applied cross-domain, cross-technology, and cross-countries. Then we are introducing analytics into the field. So we are using analytics to figure out different priorities and different parameters and network behavior to be tested during the field activities. And finally, we are putting at the center of our network testing focus the quality of experience as experienced by the customer. So next slide. Talking about industrialization, what we are trying to do is to organize different test activities in order to have complete access to the test lab from remote. It's not just a matter of using offshore capability to execute the test. It's a matter of having discipline in the process. If you can remotize something, it means that that process is well organized and industrialized. So you can measure it, you can assure the right quality on it, and you can execute it at scale. After remotizing our testing capability, what you can introduce in the process is automation. Because if you are able to remotize something, at certain extent, you are also able to run part of the process in an automatic way. And we have here our own, let's say, asset and methodologies to bring the automation at the higher level as possible in executing network testing. Next slide. As I said, we are now bringing into the field of network testing the analytics and big data added value. So basically, we are crunching the counters and the KPIs of the network to figure out which are the main areas and which are the main parameters to be optimized in order to maximize the performance of the end-to-end service as perceived by the customer. And this is done basically storing unstructured data together with network counters, together with other type of network performance indicators, together with customer surveys, and finding out the right correlation and running path analysis through this information in order to find where to execute tailored optimization campaigns. If you go to the next slide, what we want to find with this approach is the right correlation between network performances and the customer satisfaction index, in order to have a model that is describing how satisfied and how engaged is our customers with the network performances that he is experiencing. The main service that is bringing new challenges to this approach, of course, is the video service, that is really demanding and is really asking for massive resources from the network. Next slide. These methodologies has been proved also in a controlled environment by Accenture. So we organize focus group with the selected customers that are representing, statistically wise, a good average behavior of the customer base of our clients. These customers are running with their own device normal data sessions in a network that is a fake network. It's a network controlled by us, where we are generating noises, noise patterns, and any type of disturb that might occur during a real data session in a real network. And we are asking to these customers their level of satisfaction whenever they end a session in this controlled network environment, in order to match their satisfaction with the real objective performances of the network as modified by our network noise ingestion techniques. And out of this analysis, we came up with a model that is really describing the function, the relation between the network performances and the customer satisfaction service by service, as described in the last slide. So if you can move to slide 10, here we are building for each one of the main services used by the customer, so web browsing, video streaming, email servers, peer-to-peer, or even FTP, we are building dedicated models that are describing how the customer satisfaction respect to these services is correlated with the network performances end-to-end. Everything is, next slide please, ending up in our holistic network testing approach, where basically we are supporting our customers from the strategy, so defining the right approach they should have in testing their network equipment and their services, through the execution of the service, through the forecasting of the test volumes they should run, and supporting them also in the transformation in their lab management to get some cost optimization. Okay, I end up with this slide. I leave the floor to Kelly. Thanks.
Great. Great. Bruno from Expo, we're going to be coming to you next. I just want to remind our audience that we are going to be having a Q&A session at the end. So if you have questions as our presenters are speaking, please submit those and we'll get to as many of them as we can. So Bruno Giguère from Expo.
Thank you, Kelly. The topic of my presentation today will address the life cycle surrounding small cell networks and how to improve operational efficiency. Next slide, please. Looking forward to small cell deployment really means that there will be a lot more network elements to install, turn up, manage in the wireless networks. Over the last 20 years, roughly 3.3 million macro sites have been brought into service. Looking forward, there is approximately 3.4 million small cells that are going to be installed in the next 5 years. So we're looking at deploying cells at 4 times the previous rate, which really means that a lot more risk and failures as there's more aggregation site points are deployed very rapidly. To achieve this amazing growth, more complex technologies are required to manage this connectivity. Next slide, please. In trying to create a deployment plan for small cells, we rapidly come to conclusion that the macro cell model that we used before cannot really be reproduced. Although each deployment has its own DNA, on average of the time taken for each phase of the process can be estimated. So from internal studies, we found that the testing phase for macro cell accounts for about 26% of the average deployment time. This testing phase takes really into account activation, validation of backhaul services with multiple class of service that really need to be tested. And this must be done by qualified technical resources and still requires manual intervention with multiple test units. This process really requires the data collection and report generation for all phases of the life cycle of the small cell deployment. Next slide, please. To break this microcell model, a new approach needs to be implemented to achieve optimal operational efficiency. Really, the first step is to reduce field dispatch to a minimum. So extensive truck roll reduces really the profitability of the small cell deployment and really limits the velocity of these deployments. Microcell deployment process have really been refined over the last 20 years, but and it's always been backhaul through macro cells, even as evolved through the different generations. But model is really still the same, getting bandwidth to the tower and coverage to as many sectors as possible. The small cell model really incorporates technology combination of copper, RF, fiber optics, Ethernet, and depending on the approach selected for the deployment. So we're far from the macro cell model of bandwidth, base station, and antenna. To increase the deployment velocity all along the small cell life cycle, really a new test architecture needs to be implemented. So by using common test instruments with cloud-based systems, service provider can automate the data collection and provide automated test reporting. Better yet, having an automated small cell activation and service assurance system really allows for complete network visibility and provides end-to-end 24/7 service assurance. Really, with proactive analytics and actionable information, it's really possible to reduce downtime and optimize the quality of service and experience. So optimal operation efficiency really requires seamless integration with the service provider's OSS. So by reducing the service validation and activation time by 95% roughly through zero touch, really automated turn up and activation, really means that technical training can be reduced to a minimum. This automation also creates a standardized approach to testing with really greater accuracy and limiting human intervention. So looking at it, we think that this type of system would basically reduce the deployment cycle by 25%. Next slide, please. So optimizing the operational efficiency through the complete small cycle deployment life cycle, small cell deployment life cycle really means it needs to be looked at from every aspect. So every aspect needs to be revised. Without going through all of the different points shown on the slide, we're looking at really large number of additional aggregation points that are added to the wireless network. And really special attention needs to be made to the physical network. So this physical network will either be based or will evolve to fiber optics. And we think that fiber characterization and connector inspection will really become mandatory to ensure reduced field dispatch, really causing that can be caused by a faulty physical infrastructure. Next slide, please. So in every phase of the EtNet deployment lifecycle, really having an updated test and service assurance architecture will really ensure operational efficiency that will really translate into OpEx savings in the long run. We think that this operational efficiency will be required to achieve the deployment velocity, really to match the ambitious deployment plans put together by the wireless service providers. Next slide, please. So thank you for your attention, and back to you, Kelly.
Okay, great. Thanks so much, Bruno. And now we're going to be moving on to Paul Gowans from JDSU.
Okay, thanks, Kelly. Yeah, so I'm going to kind of drill down a bit and build on what Bruno was just talking about in terms of kind of what's driving our market and industry from a technology perspective and the implications of that on field testing best practices. Next slide, Kelly, please. You know, there's kind of two things driving you know, the markets at the moment. One is the whole kind of LTE evolution, and the other one is the whole kind of cell site evolution. You can just build the slide, it's fine. if we look at the whole kind of, I mean, LTE as a standard, of course, is not standing still, and it continues to add kind of layers of complexity into the domain. As we evolve LTE, we're starting to see carrier aggregation get deployed through LTE Advanced. We're starting to see the whole kind of RF and fiber worlds colliding, and I'll touch on that a bit more in the next slide. I think that's got major implications on field test. EMBMS or LT broadcast is starting to get deployed, and this is where now we're thinking it's not one-to-one, it's one-to-many in terms of simultaneous transmission from single points to multiple destinations. We're seeing much more VoLTE deployments happening. Certainly within the last kind of 6 months, in pretty well every region that we look at globally, VoLTE is starting to gain a lot of traction, and the demands that has on the network, both at the RAN level and right the way through to end. And then the last point is about kind of self-organizing, self-optimizing networks. I guess the first component of that starting to get deployed a bit more is automatic neighbor relation, but you know, the considerations for the future is as you turn up lots of cell sites, lots of small cells, lots of DAS environments, how do these things kind of self-configure and self-optimize? So really this whole kind of domain is adding complexity, and it requires us to kind of think in multiple dimensions. One is to determine that the network infrastructure, you know, can be tested and deliver what's required of it. And as VoLTE shows, the need to provide end-to-end service testing. So it's no longer you know, valid for just our kind of test environment to just think at the kind of physical layer or the lower layers. We need to be thinking also at the kind of service layer, because as we all know, a network can look fine, but the service can often tell a different story. Okay, next slide, please, Kelly. Thanks. Just a bit on the, you know, this kind of whole RF and fiber world colliding. This really is something that's happening kind of here and now, and I know has, you know, implications to anyone who's doing kind of cell site install, turn up, or optimization. Typically, you know, conventional cell sites have had coax feeds. That has got you know, certain advantages in the sense that you can get nice, easy access to the RF information. But of course, as we all know, there's a lot of disadvantages to that in terms of kind of loss and reflections and PIM, etc. So a lot of the model that's getting moved to is distributed cell sites, where the radio heads are remote from the baseband unit, and CPRI is used to carry out, you know, the RF digitized over the fiber link, and that's got lots of advantages as a means of transport. But the major implications from a field test perspective is you lose visibility of the RF at the base of the tower, and potentially the only place you can get it is right up at the top of the tower at the remote radio point, and of course you typically want to avoid that. So if you don't have a capability like RF over CPRI, which allows you to extract that RF and do your signal and spectrum analysis on that as carried over the CPRI, then you're going to be at a distinct disadvantage. So this is a kind of key you know, area where the evolution of the cell site's moving, and the kind of field test environments need to keep up. Okay, next slide. Just thinking about this in terms of kind of small cells. Small cells are kind of moving from, you know, the typical kind of femto environment to really trying to address capacity issues in an urban environment. That really is the kind of fundamental need and growth for small cells. And of course, the closer you put a user consumer to a cell site, the better service they can get. But as we know in the industry, 5 bars or 5 dots, depending on what type of phone you've got, doesn't necessarily indicate good service. So I've kind of put that in the analogy that he who yells loudest doesn't necessarily communicate the best. So In small cells, of course, the power is lower, but you're closer to the cell site. And there's lots of ways of kind of organizing this. Again, you typically don't want to be at a kind of interconnect junction point for small cells, because that really is where you can cause some boundary issues. But there's thoughts about you can use kind of low frequencies for macro and high frequencies for small cells and kind of split it up that way. Hence the kind of flute and the drum idea. Low frequencies, wider regions can go through buildings. High frequencies tend to be kind of more contained. But whichever way, you're going to have to minimize interference in this environment. And we've worked with a lot of carriers and installers in a kind of methodology around kind of interference. And it forms a kind of fairly simple path about detection. Is there interference at all? Identification, which particular signal is causing it, and then location, which is kind of what is the source. And of course, the sources we know can be lots of things. It can be other cell sites, it could be cables in the ground, it could be fluorescent lights in your building. So lots of reasons for kind of deploying small cells, but again, implications on your kind of test infrastructure. Okay, Kelly, next slide, please. Thank you. So that's been kind of LTE. Talked about small cells. Now DAS as kind of this kind of part of the whole HetNet environment. And I've kind of put it here about kind of make testing the kind of plumbing easy, because if you think about DAS is one thing we've learned from DAS at JDSU is that no two DAS installations are ever the same. But if you define a clear kind of set of procedures, as we've been working with many operators, you can certainly minimize the complexity and importantly maximize the quality experience that the end user is going to get. We mustn't ever forget that the reason for any of these things is so people can get access to their apps, right? That's the kind of fundamental reason. So you've got, there's 4 components we've described here, and think of this in a kind of plumbing analogy. You've got fiber stuff, which is all around a particular type of cable. Is it clean? Is it certified? There might be CIPRI on there. You've got coax cable certification. Maybe this is, your copper versus your plastic piping. You get a verified transmission through that. Document it. Potentially save the results to the cloud as well. Don't throw those results away. Then you've got the whole kind of RAN and RF environment. Are the antennas correct? Are they missing? Are there some faulty? What about macro cell cooperation? Again, be careful of macro ingress in indoor DAS. Maybe you want to verify the actual service at that point. You want to deploy VoLTE or something to test that. For the smartphones, and then think about your kind of mains plumbing out to the Ethernet backbone. Verify functional operation there and be able to kind of troubleshoot and resolve those things. If you kind of compartmentalize this into these components and have very kind of clear procedures around it, even though a DAS installations might all be different, you will be successful, I think, in deploying a successful DAS. And of course, this aligns with DAS, with LTE, with small cells, with any of these things. But fundamentally, you want to maximize the quality of experience for the user, minimize your time to revenue, and minimize cost. And these sort of procedures, I think do just that. Thank you, Kelly. I think that's my last slide.
Okay, great. And now we're moving on to Scott Sumner of Exedian. Just a reminder to our audience, please get your questions in, and we'll be getting to them at the end. So, Scott?
Thanks, Kelly. You can flip the slide here. I want to take things into a slightly different direction at this point. We've had a pretty good cross-section of the issues out there and different approaches and best practices to address testing. What I'd like to do is talk about what HetNet and small cells in particular have done to change the test architecture itself, or the way, the method that must be taken. And this is analogous to how SDN has also broken out the difference between the data plane and the control plane. So we'll look at some of the things that are happening here that drive that kind of necessary change in the test and measurement systems. One is essentially there's an awful lot more data happening, and small cells are a great part of that, as well as DAS and other forms of CRAN. As we move into this area, we're looking now at IP layer backhaul for the most part, reaching out past the macro sites. So we end up in full mesh environments, the X2 interface communication between sites, very important low latency connections to ensure seamless handoffs between these different roaming areas. And also a variety of different, what I would say, not necessarily carrier grade ways to extend backhaul past the macro to the small cells. So densification of this, the low cost structure means that backhaul may have to be a little bit impromptu. We can use DSL, cable plant, point to multipoint radios, licensed and unlicensed bands, and all this creates quite a bit more diversity, but also questions the quality that may be achieved here. Next slide, please, Kelly. Just looking at one of the implications, which is latency. It's quite a critical one for the performance of all the real-time traffic, streaming media, as Paul was saying, synchronization between the different sites itself, as well as call control and real-time applications. And if you look at this slide at the last macro tower where you're breaking off additional backhaul out to the small cells and all the way to the user, you're adding one-way latencies here incremental to maybe 10 to 20 milliseconds in some cases when you include the processing of the user equipment itself. And this can be quite detrimental to the overall performance of things like VoLTE calls, for example. Looking at some of the other challenges that make HetNets extremely dynamic, which means that taking a point measurement at a certain point of time may just not be valid in another location or a few minutes later. One of those is the abilities of self-organizing networks to change their own power state to adjust for wider regions when there's less demand for bandwidth or coverage. We have implications of weather, especially on point-to-point or point-to-multipoint, higher frequency links may be caused by interference or simply line-of-sight interference. The shared interference that we've been discussing to some extent here, where the small cell may be competing with macro cell in its own footprint between multiple user endpoint equipment, as well as more frequent handoffs. Next slide, please, Kelly. So from that perspective, these are the things that are changing, making testing needs more dynamic, and there's some other fundamental differences in HetNets and small cells. And as been pointed out earlier, really the cost model has completely changed. You have many more endpoints serving the customers, but they're also serving fewer customers each. They all require that dedicated performance is provided to them because of the dynamic nature and the longer backhaul we just looked at. But not at the same kind of price point or manual testing that has been seen at the macro site. So when you look at the spectrum of test and measurement equipment that's available or the options to see what's happening in the network, if you look at the price of, say, a field test set versus the network interface device that's monitoring at a tower, small form factor modules like a smart SFP that can do test and measurement functions, or even down to a simple software agent, you can see the great decrease in cost there. So most operators that are moving on small cells, notably those in the APAC region, are moving more quickly towards the software-based model and remote testing. The goal here is simply, like everything else in a network, drive the cost out as much as possible without sacrificing the performance so that you can maintain that quality of experience that the users are expecting. So some trends that are very valuable in driving out costs are making sure that your test equipment is all standards-based. That allows different types of test systems and handhelds, for example, and centralized monitoring probes to interact with the network elements themselves and withdraw metrics that would be available there, so you don't have to remotely deploy either equipment or a test set to that site. And interoperability has been verified between vendors, as well as a very open architecture to extract the data and put it into an analytics platform that may be already involved in your operational support system. Some other things that are worth observing in terms of field testing that really not being compatible with the actual needs of the network operators. One is that, as we've mentioned, analytics is required to correlate between multiple layers. If the data from a field test instrument is localized to a certain location or only has certain data that can be integrated later into an analytics engine, you're really missing the chance to provide a ubiquitous real-time feed that you'll need to do adjustments on the network and see how performance is changing dynamically as adjustments and installations are being made. Next slide, please, Kelly. So just looking at the traditional techniques that have been available, we've talked about portable test sets, and these are clearly becoming more and more expensive as there's more technologies being embedded into them. And every time a new technology comes out, you don't need to necessarily want to have to expend on additional test sets or capabilities or features. There's human error that's associated with setting them up, as they are more of a manual procedure, and having the results not there at a centralized location requires a lot more communication with a field technician and the operations center. And the other approach that's commonly used as centralized test probes also has a few inherent flaws to it, and one of them is sheer price alone. It's expensive to have a high capacity centralized test probe methodology. But more critical than that is these are central to remote site type tests in terms of topology, and traffic is increasingly, or at least the critical signaling traffic, is happening between sites, and there's no way to see that visibility. And I guess the final main point is that most backhaul networks are asymmetric now that they're extending across things like lower cost access technologies, including radio or cable or DSL or GPON or whatever's being used. A lot of them are asymmetric. So round trip metrics such as latency will only really show an average picture. They won't show the user experience's actual impact on increased latency in the network, for example. There's also a lot of traffic that would necessarily be generated from one location if you're doing continuous performance monitoring at multiple layers. So you can consider that this model of centralizing everything is running up against implications as the number of endpoints dramatically increase. Next slide, please, Kelly. So when you look at SDN networks and how they're being re-architected to centralize the control and provide intelligent decisions about managing services, delivering them, monitoring them, versus the actual data plane, which is distributed and abstracted away from that. This is a model that allows operators to meet both the needs of cost as well as scalability, and also the ability to test between locations. So the idea here would be to put the minimum amount of hardware required to provide accurate testing in key locations across the network, then leverage things like test reflectors of Ethernet OAM or TWAMP-based protocols to provide remote endpoints that are basically virtualized into the network elements that already exist. And then allow traffic generation and test to be conducted between these remote endpoints as opposed to being generated at a central location, and use the centralization for automation and intelligence and test control. Bring the data back in, crunch the KPIs, manage the synchronization and clocking between these devices for precise measurements, but don't get involved directly in the test streams themselves. And this approach is highly scalable, because if you need more test capacity, they usually are supplemented with the number of sites that you're increasing, so it's inherent to the size of the network. And they're fractionally priced compared to any other type of solution out there today, as little as 10% of the cost of traditional test solutions. This is all being done with standards-based technology and in ways that are extremely precise and real-time and granular, and open to whatever systems are there to trigger the automation. Next slide, please, Kelly. So I'll pass it back to you. Thanks for your attention.
Great. All right. Well, that brings us to the Q&A portion of our webinar today. And I want to start off actually with an audience question that I think it was submitted to Scott, but I think I'd like as many of our panelists to answer it as possible. The question is, do you think drive testing is no longer required in the modern network? And Scott, this question was fielded to you. I'm curious as to what your perspective on that is.
I think drive testing or handheld field instruments certainly have a role in the initial deployment and optimization of let's say radios as you're putting them out in the network and adding new capacity and new carriers and so on. That's important first validation before you put customers live onto it. I think one of the main concerns, though, with that kind of testing is that if we're using big analytics and more centralized correlated analysis engines to really determine if something's going wrong, what the root cause is, that a lot of these remote test platforms are not in the same traffic path, or they're disconnected from the centralized test system's visibility. So over time, I think what you're going to find is either a migration of handheld portable test equipment or drive testing equipment that can communicate directly with the centralized test resources or distributed test resources, or you're going to see new types of probes emerging for the air interface that will be extensions of, let's say, backhaul and application layer testing.
Bruno or Paul, do you guys want to chime in on the question of whether drive testing is still relevant for the modern network?
Yeah, Kelly, it's Paul here. Yes, and a good question. And given JDSU sells drive test equipment, I really should have an opinion, shouldn't I? Yeah, I mean, you know what? Drive testing has changed a lot in terms of its kind of use model. If you go back many years, a lot of operators would have had the kind of model where every Tuesday afternoon at 3 o'clock they would do a drive test, around a particular area, gather the results and do something with it. And as was rightly said, that's kind of changed a lot. It certainly gets used at the early part of deployment, because in that sense there's no traffic, so you need to generate some traffic and do some RAN measurements. But what we're finding a lot is that the need for, I would call it walk testing for a better term, but it's using handset data and potentially receiver data, but more using it in the environments that we've just talked about. So maybe it's in a HetNet environment, it's a DAS indoor environment, it's a small cell environment where you're doing kind of walk tests around the area, because you're able to do with these tools both RAN metrics and service metrics at the same time. And I said that app testing is really crucial, so being able to marry those things together is a really key part of the kind of use model. And then lastly, the point about kind of these things disconnected, absolutely, that's a key thing, right? And that's where you want to make sure that your instruments and your capture devices are cloud enabled, because you want that data in real time as you do your walk tests, but you want to capture it and load it for post analytics. So cloud enabling your instruments and moving drive tests to kind of handhelds and tablets is the kind of way to go.
Okay.
Thank you.
Bruno or Emanuele?
I think Paul very sums it up very nicely. Totally agree with that. The good old drive test in a truck is basically dying away. It does serve some purposes, but totally agree that portables and software agents on portable phones really make the difference, and especially if that data gets correlated. So Paul nailed it nicely.
Okay. Great. Well, then let's move on. Bruno, I wanted to come back to you and ask about service activation testing, and if you see new work being done in that area related to small cells. You touched a little bit on it in your presentation, but I wanted to maybe dig a little bit deeper there.
Especially on the backhaul side, there was a migration from the good old 2544 to Y1564. I know that the MEF is working on a new service activation test that's really more aimed at small cells, in the sense that basically testing from an in and I to really a uni, and looking at all those different classes of service and testing on it. So there's work still being done, which basically increases the speed to do those testing, and really makes a difference, especially when you're looking at, in the case of LTE, multiple class of services going to a small cell site.
Okay. So, we had another question about remote control of test equipment, and whether remote controlled test gear is available, and what the setup is. I'm wondering if any of our participants have insight on that.
Maybe I can jump in. Remote testing of test gear is really it's getting a bit different, where you might not be remote controlling it directly, but through the cloud you can start bringing from the cloud test configuration, and at press of a button really do your testing, and then bring back the result directly to the cloud to be correlated. So it's not really remote control of the test gear per se, but really more of an automation type system that helps the person carrying that test set to do the test.
Great. And let's see. I also wanted to ask if we could have, particularly Expo, GDSU, and Exedian, if you could offer, what you consider your top best practice tips. We've been talking a lot about implementing analytics, about the approach to some of these things. I'm wondering if maybe each of you could go through those, and Emanuele, if you have perspective there as well. So who'd like to start?
From Exedian's perspective, I think what we're seeing that in terms of value for the customers is really from a testing technology perspective, as Bruno's pointing out, there are standards that are there. If some of these are already implemented, if you can interoperate with different systems, it's not realistic that you're going to have one vendor doing the test and measurement or one type of network element in your system. So having a solution that's interoperable with all those and can centralize the results is one of the key ones. And I think the other main point that we really need to emphasize, as Bruno and Paul have both mentioned, is automation is key here. There's solutions available now where you can just plug in your small cell and it's automatically discovered, and tests to turn up those small cells are conducted automatically, and the monitoring is automatically triggered after those have passed. And this kind of installation acceleration can allow small cells and HetNets to be deployed by untrained technicians to have centralized results and make a very uniform pass-fail criteria across multiple levels of services across an entire network. So I think the keys here are automation to drive costs down, and then the same aspect in terms of standards and how you deploy your testing today.
Other thoughts on tips?
Bruno, I'll go ahead, Paul.
No, you go. Sorry, I'll come after you. Sorry, don't worry.
Okay, no problem. Really, in my case, I would say test automation, a bit like Scott was saying. It really, depending on the service provider, what has it's not, service providers will not basically throw away everything they got and start from scratch. So it's really taking what you have, look at your network elements, look at your test equipment, look at your monitoring systems, and throw in as much test automation as possible. You need to bring that data back to centralized location. You need to have that data actionable, and really test automation is the only way you'll get out of the burden of managing and installing all those small cell sites, because it's a shared number. You got a lot of things to do, and really without test automation, you're done.
Mm-hmm. And Paul, did we get you in there?
Yeah, no, I would agree with what's been discussed there, absolutely. And I would just add this thought, as we saw with the things evolution in LTE and cell site, it's just getting more complicated. And one thing you don't want to do is have to take kind of 10 devices to a cell site or a network to get things done. So we have to look at kind of smarter ways for integrating information together. I mentioned, for example, the worlds of RF and fiber coming together. So, being able to do fiber tests, separate RF in one box and do it kind of simply and move on. Other things is actually interesting because we're just talking about drive testing, but being able to take kind of RAN metrics from a kind of drive test or walk test environment and use that with your say base station analyzer, so you're integrating feed line data with RAN data. Imagine if, for example, I could take my geolocation information and integrate that with my field technicians so that it directs them as to where they need to go. And I don't mean a macro cell site, but where precisely and surgically do they need to go and fix a problem. So those sort of things about using the wealth of information you've got, integrating that into tools and methodologies will help your automated processes.
Okay. One thing that I wanted to make sure that we touched on is indoor versus outdoor testing. Paul, I think you got into it a little bit in talking about, walk testing versus drive testing. I'm wondering if you folks want to offer some perspective on, how the move indoors and that shift from, maybe driving in a car, talking on the phone, to, I'm sitting at my desk in my office using an app. How that user, how that difference in user expectation is changing testing. And Bruno, I don't know if you want to jump in there, or Paul.
I'll jump in if Paul doesn't jump in. It's really the main difference there is really looking at the small cell coverage test, where part of the equipment to install the small cell and do the test to it is fairly the same indoors or outdoors. It's really from a coverage perspective, and from an indoors perspective, really like you're saying, can really get the truck inside the office. So having equipment that is really portable in a sense that it's handheld and you can really go through walking through the different paths and do your measurement really makes a difference. And especially if you can bring that data upwards to be stored and correlated, it's really good.
Yeah, it's definitely drier indoors, Kelly, if nothing else. But I mean, again, a methodology is a methodology. I think the one thing that we do see with things like kind of DAS in an indoor environment is they're all really different. I mean, all different. It's not like you kind of go to a macro site and it's pretty standard, the kind of structure and architecture of it. I think I kind of mentioned this. Every DAS installation, our engineers get involved a lot in this. Every one of them looks the same. So every one of them looks different. So no two are the same. So there is a complexity there, which demands, I think, some extra attention. And of course, when you've got long lines of fiber and potentially connecting to long lines of coax, connecting to lots of different antennas, there is a lot that could potentially go wrong. So I think that your methodologies should be different, but they should be sort of greatly enhanced, if you like, for those environments. And at the end of the day, it's all about kind of coverage and capacity. If you don't put these things in the right position to deliver the right business benefits in QE, then you've not done what you need to do.
Okay. Another audience question. Are there the same kind of inputs coming from the different types of tools, such as geolocation, walk test, drive test, that make the job of an optimization or planner difficult, particularly if you're talking about a massive network as in India? So are we getting the same kind of data from analytics and different testing tools as we are from traditional network testing approaches?
I think it is evolving a bit. I mean, if you like, we have kind of up until this point had kind of two separate environments. We've had kind of system tools, 24/7, always on, gathering data, typically with northbound interfaces, and then we've had kind of instruments used as needed. I think as we start to, as I mentioned, kind of cloud enable those instruments, use that I mean, there's a lot of data there, a lot of intelligence there in cell site turn-up optimization. If you can use that with your system data, have kind of open northbound APIs and have that data normalized, then the kind of answer is yes. But that I think we're at the early stages, but I think it is evolving.
Yeah, and I think this is Scott here from XE, and I think there's one big difference from the type of data that's coming back from, let's say, backhaul and front haul information throughout the network as opposed to the drive test. And the most important part of that is that the data in a backhaul type monitoring is segmented. So you can see per hop visibility of what's happening at each location, where the performance may degrade. And this is where extending to the drive test equipment or to the remote field test, if you can find a way to make that part of the same test path, then you can also segment the air interface at the same time, which is going to mean that maybe not the same types of data are being brought back, but then you can correlate performance at each step find out where the degradation really lies. So that's actually an advantage of having drive testing integrating or different types of data being available.
Yeah, Emanuele here, I would like to add a comment on this. I see an additional use of analytics tools into the testing activities to focus on those attributes and parameters within the network that are generating a bigger impact on the customer satisfaction. So when you are in the condition that you cannot test 100% of the parameters, the possible configuration, etc., through analytics analysis, you can find out the higher correlation between those parameters that are mainly impacting the experience of a specific service from your customer. It is where you should deep dive with any tool you have, even drive test if needed, to be sure that you are maximizing the performances of your services.
Okay. Great. Well, we're running out of time here, so I'd like to thank all of our participants. I also want to tell our audience that yes, the slides will be available. They should be emailed to everyone who registered, and the webinar will be archived as well. So if you arrived late or if you just want to reference this in the future, it will be available. So thank you so much to all of our participants. Thank you to our audience for joining us, and enjoy the rest of your day.